So let me start this short lecture. Thank you very much for joining this session and sharing the time. And so I'm contributing to this short seminar, as one member of the Japan Society of Material Cycles and Waste Management, JSMCWM. So my name is Kushiyama. So maybe this title a little bit conceptual. So we in this seminar, I give some information for the estimation for disaster waste volume and how to use to estimate the volume by using some GIS tool such as Google Earth, and by finding the population density from the website of World Bank database. Maybe I will teach you with PowerPoint material within 30 minutes. After that, we try examination, trial program from the audience as a volunteer. So let me start to the next. So here is the table of contents of this seminar. First, I introduce how to estimate disaster waste generation, especially in Japan. And second item, I will introduce alternative. I propose alternative method and data, especially in developing country. And third item, I make a case study of prompt estimation for disaster waste. And after that, I will try some other training lecture with audience. Okay. So how to estimate whether disaster waste generation? So here is we have a two equation. Above equation means estimated amount of disaster waste. This first equation shows how we estimate amount of disaster waste that is derived from damaged buildings and houses. So estimated number is equal to summation of number of damaged buildings and multiplied by disaster waste generation intensity. So first parameter, number of damaged buildings, is counted by field survey, especially in Japan. And second parameter, disaster waste generation intensity, is described as below equation. Disaster waste generation intensity equal floor space multiplied by weight per unit space, especially ton per square meter or ton per building. So disaster waste generation intensity is derived from the result of disposal data in the past disaster. So there is many, there are several past researches in Japan. So look at to the next page. So please look into the table 1. So disaster generation per unit for demolished buildings in the past researches. So several organizations are listed, Kumamoto, Tokyo Metro, or other several cities we can see. So there's many researches done by those organizations. But we have an average number of disaster waste generation intensity per unit for wooden building. For wooden building, average number is almost 60 ton per 100 square meter, or 0.6 ton per square meter. And maybe you know there is many building types such as concrete or steel type. So those building type has a much volume rather than wooden type buildings. So the number of waste generation per unit for other buildings, so it's around 120 ton per 100 square meter, or 1.2 ton per square meter. So these numbers are used for the estimation of disaster waste generation, especially in Japan. And please look into table 2. Here is the waste generation number on flood disaster. So on flood disaster, buildings are mostly not damaged compared with heavy earthquake. So mostly disaster waste furniture, damaged furniture, or flooded electric items. So the volume number will be around 2 ton per buildings. So these numbers are waste generation per unit or square meter. And in page 5, table 3, waste per unit researched in Asian countries, especially Indonesia. So 0.08 for wooden buildings in Indonesia. This number is researched on Banda Aceh tsunami earthquake. Tsunami disaster. And there are stone type buildings in Indonesia. So waste per unit number will be 0.7 or 0.8 for other buildings, concrete blocks, or etc. But these numbers are not researched in the other Asian country. So the numbers should be researched further. So here is the, in page 6, here is an example to estimate disaster waste generation intensity and estimate the amount of disaster waste. So first equation, disaster waste generation intensity equal floor space multiplied waste per unit space. So average space number per houses is almost 100 square meter in Japan. So disaster waste generation intensity of wooden buildings is calculated as 100 square meter multiplied by 0.6 ton per square meter. So the number is almost 60 ton per building or per house. And this number put in a next equation, and we can estimate amount of disaster waste. So I make a simple scenario. So if we if one sorry so 1,000 buildings are damaged on one disaster, so total amount of disaster waste is calculated by this equation. 1,000 buildings multiplied 60 ton. This number is calculated above equation, and the answer is 60,000 ton in one disaster. This is just simple example, but maybe most participants understand this calculation. Okay, this is the how to estimate for disaster waste generation. Okay, so I go to the next slide. So far I explained disaster waste generation equation. I showed again the same equation top of this slide. And as I mentioned before, number of damaged buildings is counted by field survey, especially in Japan, but it needs lots of human resources and time for the field survey. So we propose alternative method of the prompt estimation for damaged buildings, especially developing country, because maybe we don't have well-trained researcher in a developing country. So this is the alternative method equation. Number of damaged buildings estimated by the density of buildings per square kilometer multiplied damaged area extent or affected area extent. And we can estimate number of damaged buildings from the following two parameters. One is that this density of buildings is equal with population density divided by the number of person per dwell. So maybe we can know how many buildings in 1 square meter can calculate it by the population. And if we know the affected area extent by some tool, so we can know the number of damaged, we can estimate number of damaged buildings. And affected area extent can be can be estimated by the drawing with the reference satellite image analysis or making a scenario. Okay, so from now we try case study for the uh, estimation of population density and drawing the affected area. But before starting case study, we need to prepare prepare to know the population density or prepare to draw the affected area by using some tools. First tool is World Bank database. So if participants can access in a browser, so please find this URL. I copy sorry, I'm trying to copy in chat. I try to copy URL in chat. Sorry. Now I just copied the URL of World Bank. Maybe participants can copy and put in the browser. Maybe you can find the browser page like this. Like this. And maybe you can find the vulnerability tab and scroll down to this map. Later, I will show you by using the browser. So I just go to let me go to the next slide to explain how to know the population density. Sorry. Okay, so this is the vulnerability and population map of World Bank. And the map shows around the Banda Aceh area, and each dot is indicator of population density per square kilometer. We can know number of population density by colors. And we also know the vulnerability by disaster type. So green track shows the cyclone track in the past. So we can know how often the typhoon or cyclone passed around here. And we can know density of buildings per square kilometer by population from the population density and number of people in one house. Okay, so before go to next slide, I try to show by using the browser about counting the population density or counting the building density. I put in the URL. And maybe you can find several tabs: overview, climate data, climate by sector, vulnerability. And please click vulnerability and scroll down to the bottom. I find natural hazards and map and slide bar like this. We can choose two types for some indicator. I choose population 2015 in the left side, and I choose earthquake in the right side, and by move this slide border from left to right like this, we can know if I move this slide bar to left side, we know the risk indicator of earthquake. The indicator number shows by this color bar. So red color shows the high risk. And if we move this color bar, slide bar to right side, we can know the population density as same as this color bar. So we try to find the number for the population, and by click plus mark left top page, we can zoom into the boundary area, and we can see the red dot pixel. So it shows the population density per square kilometer by in this color bar. So it's almost red. So it means the 2,500 people living in 1 square kilometer. So we can know population density in a focused area. Okay, so this is how to know the population density by the World Bank database. So I come back to the PDF slide. So as I showed in a browser, so we can know the population density like this, and we can know the density of building putting in this number. So let's go to the next slide. So from now, so we can estimate the affected area or damaged area by using the Google Earth Pro. So I also copy the download site in the chat. So it takes several minutes to download and install, but maybe it is not so difficult. Please try. If you try, please try later. If you takes lots of times, and let me proceed the procedure of using Google Earth. So maybe you can find this page. If you go to this address, and if you finish download, you can find Google Earth setup.exe, and if you install, you can find this icon, and just clicking this icon, you can open the Google Earth Pro. And I also use disaster map by analyzed on using satellite data for the Banda Aceh tsunami affected area. So this map created by the UNOSAT, United Nations Organization, and we can understand red area mostly damaged by the tsunami disaster, and gradation shows the medium or light damage. So in this case study, we try to measure this red area with this reference by using Google Earth tool. If we launch Google Earth Pro, we can find this map and put in a area name, but especially Banda Aceh. So Google Earth Pro go to the Banda Aceh area. And we can make a polygon we want, and we can change some attribute, line color, something like that, and we can know we can measure the area extent from the property. Okay, this is the procedure to estimate the area extent. So I try to show by using Google Earth Pro. Okay, please wait. I try to share the window. Now I switch to the Google Earth view. Okay, let me go ahead. So I try to make a polygon and measure the area extent around the Banda Aceh area. I put in a place name as a Banda Aceh and search area. Okay, sorry. So I have already done test, but you can find some icon button, and maybe you can find add polygon button. Please click this one and keep new polygon property and put in a name you like, and still keep this window. And how to make a polygon is like this, by clicking each corner point and just click OK button. So if you would like to modify this polygon, please click on right click on polygon name and go to the profile. Maybe you can see the red point corner, and each corner can move like this. And the color can be changed by style color tab. So if you choose outline and line color, and width of line, maybe you can find the modified polygon. And we have to know the area extent in a square meter. So please find measurements tab and change the unit, square kilometer. So we can find the number of area extent. In this case, 28. Okay. So this is the making a polygon and measurement of area extent. Okay, I go back to the slide. Okay, so far we can know population density and area extent. We use those number and we estimate disaster waste generation. And please look at slide and look at each equation. Firstly, we try to estimate density of buildings. Population density, we can know population density as 2,500 and much divided by the number of people living in one house. In this case, we choose 4, and we can know 625 buildings per square kilometer. And next, we estimate number of damaged buildings in equation 2. So density of buildings per square kilometer, 600 to 25. And we need to change, sorry, so let me. Sorry, let me change the number. Now we can know number of affected, square kilometer of affected area by using the Google Earth. The number is 28. So 625 multiplied 28 equal to 17,500 buildings in the affected area we imagined. And before going to the equation 1, we need disaster waste generation intensity. So this number is has been researched in the past research. And in this case, we try to use this number 0.73, and we put the space of one house as 100 square meter, and disaster generation intensity is 73 ton per building. And put this number into the equation 1, we can estimate this equation. Like this. 1.2 million ton, maybe. So now I just tried calculation by using the calculator. Maybe it's okay. So these are how to estimate disaster waste generation by using the World Bank population density database and Google Earth 2. Okay, so I would like to more exercise. Would like to do more exercise with some audience. So, but あれいいのかな Is it okay to go ahead? So there is
Okay.
some question or comments from the, is there any comments from the audience or participants? May I go to more exercise? Okay, so let me go ahead. So I need 2 volunteers. So I have already asked students in university. So Miss Coco and Miss Dima. Okay. Are you ready to do exercise?
はい。
Okay.
はい。
So
Yes.
thank you very much for the supporting us. Okay, so I would like to firstly Coco-san try.
Yes, I will
Okay.
try.
I want you to I want you to find population density in your hometown, and after that make a polygon by using the Google Earth. But maybe we don't know which area will be damaged by earthquake. We don't know the future. Just please just imagine the area as a scenario, just a scenario, okay?
Yeah.
So please share, can you share the browser of
Yeah.
World Bank? Okay, good.
Yeah, this one.
Yes.
And it's my hometown. So
Mhm.
at first I need to find the country, right?
Yes, please.
Country. So this country. A little weak about the Wi-Fi. So read country field.
Okay, so can you go back the
Yeah.
map view?
This one. Yeah,
Okay,
get it.
yes. Let's please
So I
choose.
get China.
Yes.
Okay, I come from China. And I got that. So I choose the
Vulnerability, yes.
vulnerability. Sorry, a little slow.
Maybe all participants Wi-Fi performance.
Yeah, today slowly. Yeah. And okay, so this is China.
Yes.
So this is my hometown.
Mm-hmm.
It's in the Shandong province. So
Shandong province.
yes. So this is Qingdao. So next Qingdao is Rizhao. This is my hometown.
Mm-hmm.
Okay.
So let's show the population density in the left side.
Okay, got it. Can I choose the population 2015?
Yes, please.
Okay. Okay, get it.
Almost right.
Almost right, yes. Yes, the Chinese population, especially in my hometown, is very, yes, very, the dentist is very so closed, so high. So then I will choose like, because my hometown is near the seaside. So at first I will choose I want to choose the earthquake part.
Yes, please.
So Okay. So yeah, this Shandong, I think so it's not so strong. Yeah, it's not so strong about this earthquake part. But we have it, I think. So compared to, yeah, it's not so strong, I think,
Yes.
for the
Japan,
earthquake.
more
More
higher risk.
higher, yes, it's a yellow part, yes. And so Shandong, this is maybe this is Kyoto University being here. Okay, our next we'll choose the circle column. And there, let's visit. Oh my God, yeah, it's strong. I think just in this circle, I think compared to Japan, it's not so strong, but we still in the disaster part, I think.
But maybe several times in a year,
yeah,
cyclone passed.
Yes, several times. 1 year, maybe only 1 or 2 times, I think. Not so frequency. Okay. So can I choose another one? Try to see that. Maybe Storm Sorger. The last change one. Oh. So how could I see that?
See the green line or red line along with the coastline.
Oh, yeah, this part.
Yeah. Maybe storm surge caused by the heavy wave.
Heavy wave, okay. So it's just on the sea line, maybe.
Yeah.
Okay.
Yes.
Got it. Thank you so much.
Yes, thank you.
Okay.
So now we understand that your population index very high in your hometown.
Yes, very high in my hometown.
Yeah,
so many people. Yeah.
Yeah. So okay, thank you very much for your supporting. So, and Dima-san.
Yes, hello everyone.
Hello.
My name is Dima and I am from Bulgaria. So I will maybe like to show you again how to use the polygon tool in Google Earth to, let me share my screen.
Please.
There we go. So Bulgaria is in Europe and it's this little country here. But we will go into the search tab and I will search for a village's name, which is Nikolaevo. And it's an area that was affected by a flood in 2014. And I believe in 2017, again, they had a similar problem with the river and the dams along the river. Here we go. 1 second. So I would like to zoom out a little bit. So 1 second. Okay, so if you can see, this is the river, and then it reaches this lake near Panicherevo. So I will zoom out a little bit more. I know that the affected area in 2014 was somewhere from Jagoda here to the lake. So to measure this, I would create a polygon.
Yes, please.
Again, I would change the name to 2014, let's say. Oh, I forgot to mention, this is a flood affected area. In my country, floods are probably the biggest natural disaster. So I create a polygon with with this name. And you should not close the window while you're still creating the polygon. So I will select roughly the area that was affected. I think this is about it. And then again, we can go into the color and we can choose a different color to mark the area, of course. And again, if we go to measurements here and change the data to kilometers, it's around 306 square kilometers that was affected. That's around 2014. The river and the dams nearby just were over flooded because of very strong rains.
So 300 square kilometers, so maybe huge, largely damaged than, so how to say, so compared with the Japanese other disaster affected area.
It is a very big area that was affected, but I think it wasn't as strong as other places get affected, because it was just because of very strong rains and over flooding of the river. It was a big area, but it wasn't that damaging, I think. A lot of basements got flooded, but buildings were not destroyed, and not many people were actually hurt.
Okay. Okay, thank you. So can you find the population density by using the World Bank database?
Yes. Oh, sorry, 1 second. I will share the other part.
Yes.
Okay, so we can go to the World Bank and we go to country. Again, I will select Bulgaria. Oh, sorry.
It seems some problems due to the
1 second.
Oh, okay, vulnerability.
Yes,
Maybe
but this is for Indonesia, so I have to go. I hope it doesn't have the same issue now. Oh, why? Sorry.
no problem.
1 second, let me stop sharing just for a moment.
Yes.
Sorry. It keeps doing the same thing for me. I think it's
Okay, so
YouTube.
may I do by from my browser?
Yes, you could do that.
So can you see my browser around the European area? So
yes, so yes. Yes.
Nikko.
So no, well, it's a very small village, so you wouldn't be able to see it. But over there, where you see Stara Zagora, SDA, just above your pointer now.
Around here?
Just a little bit. Yes, it is around. Yes, around where your pointer is now.
Okay.
It's the affected area. So if you
between Stradzagora and Dimitrovgrad.
yes, it is near. So if you slide over the population, it is not. It's not that heavily populated. It's not that dense of population, like China, for example. But my country isn't very heavily populated in general. So we can see that the density isn't that strong. Oh, we could change cyclones maybe to floods.
Floods. Okay.
And then over here you can see that's the river that creates an issue sometimes. I think that mostly it is bad infrastructure and just not very good waste prevention, disaster prevention in my country. And I think that this causes floods sometimes in rivers and dams.
Around this river.
Yes.
I'm not sure. Yeah, but flood happened in around the area. I see. Okay, thank you very much for your supporting. Okay.
Welcome.
And I go back to my slide. Okay, thank you, Rima-san. Okay, I go back to my slide. So, by supporting two volunteers, we can know the population density in your town. For example, maybe Rima-san case 100 per square kilometer, and maybe 25. And density of buildings is 25, and affected area almost 300 square kilometer. And we know buildings number. In the area, 7,500 in the area. And we can know, we can estimate the amount of disaster waste. But in flood case, the buildings are not so damaged. Maybe furniture or electric items will be disaster waste due to the flood. So number of generation intensity not so high. In Japan, we use 2 tons per buildings in flood case. So the number 15,000 tons. This is the prompt estimation for the disaster waste in a flood case. So, so far, I showed the case study for the prompt estimation, disaster waste. So that's all of my presentation. But do you have any comments or
Mr. Kushiyama, is there a question from one audience? Is there man-made disasters on this website?
Sorry, I cannot see the.
Is there any man-made disasters on this website?
Man-made disaster?
Yes, because this is only natural disaster tab.
Yes. Man-made disaster means how to say so. Nuclear なんだっけ
natural disaster only.
Yes, the website shows only for natural disaster. So sorry, so far I don't know the man-made disaster. Maybe so I go back.
Man-made disaster like Lebanon's Beirut explosion that happened in August 2020.
We cannot see. I go back the. Database. So we can there's no man-made disaster in the list of World Bank database. So sorry, I don't have any information about the man-made disaster. But if we later, I will check some information in other website.
Thank you very much.
Yep. Okay, so today's lecture is almost finished. In the last, I show you website URL following this seminar. So maybe if you access this URL, you can find some, maybe you can find some archive video or presentation materials. So we appreciate if you access this website. And I say thank you to all participants and supporting by the two listener, Koko-san and Rima-san. And
thank you so much.
Yes, thank you very
much.
So may I finish this seminar? Yoshimura-san, okay?
Okay, thank you very much.
Yes, thank you.
Kushiyama and students, all participants, thank you very much.
Okay, thank you very much for joining this session.
If you, Mr. Kushiyama, if you can share the website, please paste.
Sorry, ちょっと待ってね。Okay,
thank you.
I just copied website for archives in a chat. Maybe we will be happy find this page. Okay, thank you very much again
Okay,
for
thank you very
joining.
much.